Hi everyone, so now we're going to be talking about how to solve two-step equations. And solving two-step equations is a little bit harder than one-step equations, but it's not too crazy. In this case, we have to get two numbers over to the other side to get the variable by itself. And the only tough part about this is to determine which one goes first or what number we have to move over first. And the way we're going to figure that out is with backwards PEMDAS. So if you remember, order of operation follows this thing called PEMDAS, which stands for parentheses, exponents, multiply, divide, add, subtract. So when we solve equations, we're actually going to flip that around and make it SADMEP, which doesn't sound nearly as nice. But when we solve equations, we're going to use this one, which tells me that I have to subtract and add first, and then multiply or divide. We're not going to use a lot of the exponents and parentheses, so that's just kind of extras and something that'll happen in years to come. But when you get more complicated equations, but in this case, we just want to understand that you have to add or subtract first, or get rid of the adding and subtracting first, and then you can get rid of the multiplying and dividing. So let's start going through some examples. The first example is 2x minus 6 equals 10. Okay, so when we solve this, the first step is to draw this line down the middle of the equal sign. And now we know that we have to get rid of the 2 and we have to get rid of the 6. And like we just talked about, we're going to have to add or subtract first, and then we multiply or divide. So which one, now we have to figure out which one's adding and subtracting, and then which one's multiplying or dividing. In this case, I can see that the 2 is right next to the x, which means it's multiplying. And then you've got this minus 6, which means it's subtracting. And so based on this backwards PEMDAS, we have to move the 6 first. And because the 6 is subtracting, we're going to do the opposite, which means we're going to add the 6 to each side. All right, and then we're going to treat it like a big addition problem. And on the left side, the negative 6 and the positive 6 cancel each other out, and we're just left with 2x. And then on the right side, we have 10 plus 6. 10 plus 6, which gives us 16. All right, now we're not done yet because it's a two-step equation. We only did one step so far. But now it looks like a one-step equation, which is something that we've already done. And we know that the 2 is multiplying the x. So to get rid of it, we would have to do the opposite, which means we're going to divide both sides by 2. The 2's cancel each other out. They create that 1 like we've talked about. X is by itself, and then 16 divided by 2 gives me 8. My final answer is x equals 8. All right, let's go through another example. This example is 5 plus w over 3 equals negative 10. Once again, start with a big line down the middle of the equal sign. Now, we know we want to get w by itself, which means we've got to move the 5 and the 3. We're going to use backwards PEMDAS, which means that we have to get rid of the adding and subtracting first, then the multiplying and dividing. As we can see on this equation, the 5 is adding and the 3 is dividing. So we want to get rid of the 5 first because it's the one that's adding. And because it's adding, we're going to get rid of it by doing the opposite of adding, which means we're going to subtract 5 from each side. All right, on the left side, these 5's cancel each other out. We're just left with w over 3. Then we've got on the right side negative 10 minus 5, which gives me negative 15. All right, now we're not done yet. We still need to get rid of this 3. The 3, because it's in this fraction, the 3 is dividing the w. So to get rid of it, we do the opposite of dividing, which means we multiply each side by 3. And once again, the 3's cancel each other out. We're just left with w. Then on the right side, we've got negative 15 times 3, which gives me negative 45. All right, so now we're going to look at a couple more examples, and these examples are where I'm going to put my foot in my mouth, and we're going to, we're going to multiply or divide first and then add or subtract, but you'll see why. Okay, so in this case, we want to solve for t. Now, as you can see, you've got this set of parentheses. And what the parentheses do is it tells me that I have to multiply the -3 to both the t and the -2. Because I'm multiplying that 3 to both chunks, to get rid of, if we want to solve for t, we have to get rid of the -3 first. Because if I were to get rid of the 2 first, that I can't take that 2 outside of the parentheses. It doesn't work like that. So I have to get rid of the -3 first because the -3 is multiplying both the t and the 2. So really, like I guess the trick to remember is that if you see a set of parentheses, you have to divide first and then you can add or subtract. So we know the -3 is multiplying. To get rid of it, we're going to divide by -3. The reason why it's negative is because that 3 on the right side is negative. We have to get rid of the whole thing. So the -3's cancel each other out. And on the right side, we're just left with what was inside the parentheses. We can take it out of parentheses now because there's nothing that's multiplying it. And then on the left side, we've got 9 divided by -3, which gives me -3. All right, so now it's a one-step equation. We want to get rid of the -2 now because we want the t by itself. The 2 right now is subtracting the t. It's t minus 2. So to get rid of it, we do the opposite of subtracting, which means we're going to add 2 to each side. The 2's on the right side cancel each other out, and we're just left with t. And then we've got -3 plus 2 on the left side, which gives me -1. And my answer is -1 is equal to t. This is opposite than what we normally than what it normally looks like, because we normally see that the variable's on the left side. So I could write this as t equals -1. Either way works. Totally fine. All right, now let's look at one more example. So on this example, we've got y plus 4 all divided by 3 equals 7. Okay, we're going to draw a line down the middle of the equal sign, and this is very similar to the example that we just did, because notice the 3 is on the bottom. It's dividing, but it's dividing both the y and the 4. So I can't get rid of the 4 yet, or I can't get rid of the 4 until I get rid of the 3, because the 3 is doing something to both the y and the 4. So we know that the 3 is dividing because it's on the bottom of a fraction. To get rid of it, we have to do the opposite of dividing, which means we're going to multiply each side by 3. On the left side, the 3's cancel each other out, and now I'm just left with the top of the fraction, which is y plus 4. And then on the right side, we've got 7 times 3, which is 21. All right, now it's a one-step equation. As we can see, that the 4 is adding to the y just because of that plus sign. And so to get rid of it, we do the opposite of adding, which means we're going to subtract 4 from each side. On the left side, the 4's cancel out. We're just left with y. And then on the right side, we have 21 minus 4, which is 17. And there we have it.